Hello and welcome to the stream. My name is Josiah and I am a space engineer, and we're here today to see the launch of the H3 rocket. This is a completely new rocket that has been developed in Japan by Mitsubishi Heavy Industries, and basically this could be a rocket that would actually be competitive with the Falcon 9. So it's a very I guess a new way to try to compete with this rocket. It's not actually reusable, but still somehow they're able to hit some similar price points and some similar performance to what the Falcon 9 is capable of. So, uh, with development on this type of a rocket, I guess it's really exciting, and we're about to see if it's really worth all the hype. Can they actually perform where they say they want to be performing? Of course, the Japanese Space Agency is prolific for trying to develop low-cost vehicles. They actually have one of the lowest cost vehicles that are out there, or how should I say, lowest mass vehicles. I think they hold the record for the lowest the lowest mass rocket to reach orbit. So if anyone's going to be able to do it, hey, why not the Japanese? So I'm really excited for this launch because, of course, the H3 is really a kind of taking a pick to the Falcon 9 and trying to eat into a bit of its market share. And so it could be a really good story for the future of H3. And it's also really good to see some competitors to SpaceX so that we can keep driving that cost of space downwards. Because if no one really competes with them, well, they'll just kind of stay where they are and not really get any cheaper. So, over the course of the next hour, just so you know, the time for the launch is in about 48 minutes. You can see it in the clock below. It might not be exact to the second because, there's maybe a couple seconds of lag on the stream and stuff. So just keep that in mind. But it's going to be in about 48 minutes. We're going to hopefully see this rocket launch. Again, it's a new vehicle. So, there could be some things along the way that might stop the process, or there could be some technical glitches. This is still rocket science, so anything can happen. But I always like watching the first launch for vehicles because it's kind of like that point where there's a lot more that can happen. It's kind of like less known what can happen, and there can be a lot of weird things that can happen, and it's good to kind of see what's going on with the development of a rocket. And that first launch is really kind of that developmental step that is taking you from being this test piece to finally having something actually performing where you want it to. And sometimes that transition can be a little rocky. And it's cool to see that kind of in action. So I hope you can join me, and let's watch this rocket launch.
So weather is one of the important conditions for launching these launch.
So right now they do have a stream in English for that JAXA is preparing. So that's the one we're going to be tuning into regularly. It's just this one right here. So yeah, we look forward to some commentary from the from JAXA as well along the way here.
There is a place called a Launch Control Center (LCC) that conducts various types of.
But before we get into their live stream, because they're mostly just going to be kind of talking fluff right now, I kind of want to get into a little bit more of the actual nitty gritty of why this vehicle is so interesting. Yeah, and I hope you can learn along with me with what is new and innovative about the H3 rocket, because there are some interesting things under the hood. So I think the first thing that we should keep in mind is that this is actually a family of vehicles. It's not one rocket itself. There's kind of like 4 different configurations that you can put this rocket into. And today we're going to be launching the H3-22S. And so, yeah, you can kind of decode what their system for speaking is by using the pointers that I put here. So basically the first number there is indicating how many engines are on the core stage. The second number is indicating how many boosters are on the rocket. And then that third letter is indicating whether it is the small body or the long body. You can see that the 32L and the 24L are a little bit longer. And that's just because they have more boosters. So, of course, they can handle more weight on top. Basically, they want to be able to configure this rocket at any of these 4 different configurations, and they can kind of make it a little bit cheaper if the payload's a bit smaller, and they can, not have it be so much more expensive for a bigger payload because it's just a kind of a small modification to the vehicle itself. And yeah, with this family of vehicles, they might be able to be competitive with the Falcon 9, but let's see a little bit more about that in a second. So if we get into the rocket that's launching today, which is the H3-22S, so that means we're going to have two engines on the bottom of the core stage, and we're going to have two boosters that are on the side of that vehicle. So it's kind of the mid-power range of the vehicle that we're going to be testing today. And you can get an idea of some of the stats here just by looking at these dimensions and figures. So it's about 63 meters tall, which is a relatively large rocket, I would say. That's equivalent to, like, I don't know, probably like a 15-story building or something. The main diameter is 5.27 meters, which again is quite thick for a rocket. This is kind of getting into that, thickness that you would see on something like the SLS. Not quite that thick, of course, but the reason for this is because it's actually running on liquid oxygen and hydrogen. And of course, hydrogen is a super light fuel, so it's very spacious. So getting a lot of it into a small space is kind of difficult. So this ends up having rockets that are a little bit wider in order to accommodate this. In the end, the takeoff mass is only 450 tons, so it's not like that 5.27 diameter you can see is not really causing it to be a crazy heavy vehicle. It's just that it's carrying hydrogen, so it ends up being a bit bigger. In the end, the payload capacity is going to be around 6,000 kilograms to LEO and 3,000 to 4,000 kilograms to GTO. Today, the vehicle is just going to low Earth orbit because it's a test mission, and it's taking a couple of satellites. They're not weighing on the order of 6,000 kilograms. So it's just, again, they're testing out the vehicle, trying to make sure everything's working properly. And of course, it's a 2.5 stage vehicle because we have the boosters, which are radially attached. And then we have a core stage and then a second stage that's above that. So that's kind of how the vehicle is configured. Let's get a little bit into the engines that are powering that core stage because they're a little bit interesting. And there's kind of the reason why this rocket is somewhat cheap in the end. Basically, they've gone into a whole development process where they've been making an engine which is using the expander cycle, and that's the cycle that you see on the right here. I know that it's kind of like a bunch of tubes and stuff, but basically what's happening here is that the fuel is acting as a medium for transferring heat from the nozzle of the combustion, and it's using that heat to drive a turbine, which is then running the pumps. So essentially you're using the heat of the engine itself to pump the fluid into the engine, and it kind of is like a self-circulating system which goes as long as the engine is on. This particular cycle they're using is called a bleed cycle. So that fuel that goes through the nozzle and then pumps the turbine, which then drives the pumps, that fuel just kind of gets thrown overboard. So it's a little less efficient, but using this method, you can actually get a lot higher thrust, which is why they can be used on the core stage in this matter. Usually you just use expanders in space, but here that expander cycle is actually being used on the ground. So in that sense, it's kind of an interesting idea because you can actually build a rocket a little bit simpler using this cycle. And in this case, JAXA is looking at trying to make it cheaper. So let's see if it's actually going to pay off for them. Yeah, here we can see them testing these engines back a couple of years ago. Yeah, you'll just notice that you can see on the sides of the engine that there's like some smoke coming off the side. That's the bleed cycle. So it's basically bleeding off hydrogen out of those tubes, and that's not being ignited. So it's just kind of flowing down the outside of the rocket. And it's that hydrogen which is actually driving the pumps themselves. So it's kind of a simple way to drive your pumps instead of having like multiple combustion stages. And that's what's going to make this rocket a little bit cheaper and hopefully be a kind of a cool, innovative way for them to launch a rocket into space. I don't think we've ever had an expander cycle engine on a core stage of a rocket before, but don't quote me on that. So let's head back to the live stream here, see where we're at.
So it is a 5.2 meters all the way up. So it looks quite heavy, doesn't it? Yes, that's right. So far, H2A rocket and H2B rocket carried the word Nippon on their sides. Nippon means Japan in Japanese, but now it says Japan. Yes, that's right. The Japanese baseball team is doing quite well. So the word Japan is well known to a global audience. And we talked about making inroads into the global space as well. So we wanted to change the name to Nippon to Japan, which can be understood by international audience. This is quite meaningful. So the world this H2 rocket is launch vehicle is trying to realize, as well as the development journey. We have a video, so please enjoy.
So here's a simulation of the vehicle as it goes up, maybe? I don't know.
1957年に旧ソビエト連邦、現在のロシ
Interesting.
アが世界初の人工衛星スプートニクを打ち上げて以来
So here, while they play this, I just want to go over the staging sequence that we're going to see for this launch. So like for any rocket, there's kind of like a bunch of steps that are going to happen along the way here. So first, of course, the rocket's going to launch, and that's going to be the ignition of the core stage plus the radial boosters. All of them are going to fire at once. The core stage actually doesn't quite have enough energy to lift itself, or lift everything by itself with just the 2 engines on the bottom. It can actually do it with 3 engines, which is one of the configurations, but with just 2, it needs those boosters in order to get off the pad. So yeah, those 2 boosters and the 2 engines have to fire all at once, essentially. Then after about 100 seconds, you're going to see the separation of those 2 boosters, and they're basically just going to fly off radially, and then the core stage will be basically heading all the way out into orbit. So the core stage will not stop igniting at this point. Then after some minutes, the first stage will run out of fuel, it'll turn off, and then it'll separate from the second stage. And then in the second stage, you can see a much bigger engine bell, basically, and it's basically a space nozzle. It's also running on liquid oxygen and hydrogen, but it's not quite the same engine. It's I think it's an LE5 or something. Yeah, it has a little bit higher performance because, of course, it's designed to operate in space. Then we're going to have the ignition of that second stage, and then that's going to be what carries the payload all the way into orbit from that point. And we're also going to see the fairings separate. Now, I'm not sure exactly when the fairings are going to separate. They might separate before you see the separation of the first and the second stage. Yeah, of course, I haven't seen this vehicle launch yet, so I don't actually know when it's going to be. But we're going to find out. So watch out for that moment in the flight. I hope they have onboard cameras. I'm not sure exactly what JAXA does for their live streams, so we'll find out if we actually get to see a onboard camera view. If you just have the tracking cameras, you're probably not going to see this step, just so you know. Yeah. Next, I just want to talk a little bit about why this vehicle is interesting in terms of like the matchup with the Falcon 9, which I think is basically the vehicle this rocket is trying to compete with. It's kind of quite clear, especially when you look at the statistics. So yeah, if you put them beside each other, you realize actually it's almost like they're the same vehicle in terms of performance anyway. So yeah, the height of the H3 rocket is going to be 63 meters. The height of the Falcon 9 is 70 meters, so they're relatively similar there. The H3 is, of course, a bit wider at 5.7 meters diameter, and that's just because it's running on hydrogen. The Falcon 9 runs on RP1, which is a much denser fuel, so they can get away with a much smaller diameter for their rocket. But if you look at their thrusts, they come out pretty much equal. If you look at their payload to low Earth orbit, the Falcon 9 is a little bit ahead in that category, getting 17.4 tons to low Earth orbit, whereas the H3-22S is only able to get about 10. But it's in the geostationary transfer orbit where things get interesting, because there the H3 rocket can potentially get up to nearly 8 tons, whereas the Falcon 9 is really only able to get 5.5 or so. So this is a place where basically the H3 rocket could actually outcompete the Falcon 9. And the other place it can maybe outcompete is on cost, because you can see that the H3 rocket is right now being marketed as a vehicle that will be between 50 and 65 million. Of course, that'll depend on the integration, on the type of H3 rocket that you use. So of course, on the cheaper end, you'll have the one without any boosters, and on the expensive end, you'll have the one with the 4 boosters. Of course, all of these rockets are technically cheaper than the Falcon 9, which is being marketed right now at 67 million. So it'll be interesting to see if the H3 rocket can prove to be successful and reliable, if they'll actually start stealing some of the market share of Falcon 9. Maybe we're getting a little bit ahead of ourselves, but that would be certainly exciting and might incentivize SpaceX to maybe hurry up along with that with Starship, because of course they'll need something better to compete with at that point. Anyways. Yeah, the Japanese Space Agency, Mitsubishi Heavy Industries, they're looking to, of course, get back into the space race and hopefully upset SpaceX in their current domination status. Here we have a little bit about the LE9 rocket that I was talking about. Let's see here.
高いレベルで両立することが可能となります。次に LE9 には 3D プリンターで製造した部品がいくつも使われています。
Yeah, so they even 3D print this rocket, which is really good, because for an expander cycle engine, you actually have a whole bunch of flow channels that are in the nozzle itself. So like there's little tiny channels that are in the nozzle, and that's where the fuel can get injected and can basically cool the nozzle as it's going, and also it can use the energy of that heat in order to drive the turbines. But in order to make those channels, it's really difficult if you just like do it conventionally. But if you have a 3D printer, you can actually print the channels into the thing itself. So you can just you can print basically any sort of geometry and dimensions with a 3D printer. So it makes manufacturing way easier and theoretically a whole lot cheaper. Yeah, just another advantage to modern manufacturing techniques, which allow different types of engine cycles to be actually cheaper in the end, whereas in the past they may have been a lot more expensive. Another interesting thing that you're noticing there is that in their engine testing, the flame of the rocket is actually clear. And the reason for this is that, of course, it's burning hydrogen and liquid oxygen. And if you burn those, you get kind of a clear / light bluish kind of a flame. So you actually really won't be able to see the core stages engine exhaust plume in comparison to the solid rocket boosters, because those, of course, make a giant plume. And that's just because they have a lot of particulates and stuff that basically shine really bright when they get shot out of the exhaust nozzle. But yeah, this is definitely a cool looking engine in my opinion. It's with all the flow channels and everything, and seeing that expander bleed cycle. Yeah, I'm looking forward to seeing it launch for sure. I hope you are too.
How did you enjoy the video? That was the overview of the H3 launch vehicle as well as the feelings of developers. So Mr. Kodani, how have you been involved in the H3 launch vehicle? I worked with those who are in the video, so about 10 years ago I joined a team before the project was called H3 project. It was called Next Base Rocket or Launch Vehicle or something. I was in the concept team, so I wasn't able.
For those of you just joining, of course, this is the live stream of the H3 rocket launch, which is Japan's it's going to be its new flagship launch vehicle, and it's in a family of launch vehicles, and this is going to be the first test flight of this particular configuration of the rocket. We're really excited to see this thing launch, and it's potentially going to be something that will compete with SpaceX and the Falcon 9. So if everything goes successfully, we're looking forward to a potentially bright future here where they could maybe be starting to push SpaceX to maybe push their prices down a bit, which would be great. So yeah, just to give you an idea, if you missed it at the start here, the H3 family is basically these 4 rocket configurations. And what's the difference here between these different configurations has to do with the number of engines and the number of boosters that are going to be kind of all attached together here. So today we're going to be launching the H3-22S, which is the second configuration, which means that we have 2 engines and 2 boosters. And you can kind of figure out how many engines and boosters you have based on the numbers that are in that code. And I've kind of explained it here just in this picture. So basically the first number is how many engines you have on the bottom, and the second one is how many boosters you have attached to the side. And yeah, if all is successful, then this will be a vehicle which can be used to launch payloads for a lot cheaper, potentially, than even Falcon 9.
Is a fuel. So this fuel accounts for 90% of the weight of the launch vehicle. Did you know? So yes, you see the vehicle, and pretty much all of it is a fuel tank, isn't it? Yes, the orange part is the insulator for the tank. So most of the body is the tank.
Yeah, you'll notice that the tank is all orange, which is kind of looking like the space shuttle fuel tank. And that's because they're using the same insulation on that tank, because of course they're using the same fuel, which is hydrogen. One of the tricks about using hydrogen is that you really have to cool it down really, really cold, like even colder than for liquid oxygen. You basically have to go down to minus 250 degrees Celsius, which is only 20 degrees above absolute zero, which is like crazy cold. And keeping it that cold is quite a challenge. So they have to insulate these tanks with like really, really thick foam insulation. And that's that orange insulation that you see. They're still using it today, even from when it was developed way back in the space shuttle era. So here, let's learn a little bit about the payload, which is ALOS 3. It's going to be an Earth observation satellite. They've basically got some really good cameras on this thing, so it should give them some really good data. So the orbit that they're actually going to be putting this guy into, the Almos 3 satellite, is going to be a sun-synchronous orbit. Of course, they're launching this satellite from Japan, so it's not very far, like, south towards the equator. So really the only useful orbits that it can actually get from the launch site that it's launching from is going into these sun-synchronous or polar orbits. So basically, instead of going around the Earth like at the equator, it's going to go north-south. So it's going to go over the North Pole, under the South Pole. And that's really good for Earth observation satellites because, of course, Earth is spinning underneath that orbit. So basically the satellite can see the entire world because it'll just keep passing over, and as the Earth rotates, it'll kind of come to a new section on each orbit. And over the course of like a day or two, basically you have total global coverage, which is the whole idea of an Earth observation satellite. And based on the capabilities of this vehicle, the H3, it'll definitely be like the most competitive vehicle for going into these types of orbits. especially when you consider like ride sharing and stuff. Like if you can put a whole bunch of small satellites onto this thing, and you can get some really, really cheap prices. I would assume some that are even better than the Falcon 9. So it'll be interesting. It'll be interesting competitive space between these two vehicles, provided that this one is actually successful.
It's getting a bit hot, isn't it? I put off my jacket. So how did you like it, Mr. Kotani? Yes, that's right. So since compared to Daiichi...
I'm not sure what language that is. Unfortunately, I do not speak it. I only speak English, I apologize. And a little bit of German.
If you use a digital camera, it may be easy to understand. It's like a number of pixels. So that is a 70 kilometer observation range and 0.8 meters. If you compare that to the number of pixels, if you have as many as that, you can recognize a car. I think it's still hard to imagine, but if it's a TV, it's like a high vision, a TV becoming a 4K camera, a TV. So it is quite a evolution, isn't it?
Yeah, the resolution they're getting there is pretty decent.
Images, then the amount of data
at 0.8 meters, you can basically, like, you can almost see a person. Not quite, but almost. Yeah, so yeah, for when the launch is, it's going to be at, 10:37 in Japan, which is in about 23 minutes. Is that my, just let me switch back to my clock here. Yeah, 23 minutes. I have the clock right here. So in 23 minutes, we should see this rocket launch. It's actually a 7-minute launch window, so they could launch anywhere from 23 minutes from now to 30 minutes from now. And it's a tight launch window here. It's a tight launch window here because they're going into the sun synchronous orbit, so they kind of have to hit a specific window in order to get this satellite where they want it to go. So yeah, it's not quite instantaneous, like as if they were trying to rendezvous with something, but they still have a specified place they want to put this satellite. So that's the way it is here this time. But yeah, we're launching at 37, which is in about 22 minutes. And this ALOS 3 is, I believe, the only satellite that's on the vehicle right now. Again, this is a test mission, so they're not, being too ambitious and putting a whole bunch of payloads on there in case they don't make it to orbit, which is quite often for starting vehicles. So just keep that in mind. Keep your expectations at bay. But I think we're probably going to have a successful launch here because they've basically tested the hell out of this thing at this point. They've been testing these engines out for years, and yeah, I'm really excited to see them fly.
その集大成として、実用に供しうるレベルの光衛星間通信の実証できることがルーカス開発担当としては非常に大きな喜びでございます。加えて特に今回
This optical communication thing seems a bit strange. That's definitely... I'm not a communication expert, but the way I understand it is basically the shorter the wavelength you use to communicate, the more information you can communicate with. But the tighter your signal, like the better you have to be at pointing your beam at the ground. And with light, you basically have to be perfect.
So the data that were transferred, how are we going to utilize that in our society? That's going to be a lot of fun to think about. Yes. In regards to those people who are involved in the data usage of H3 or ALOS 3, we've asked about how they are using that data and how they're distributing data. Please take a look.
PASCO は航空写真測量の会社として創業し、今年10月で70年を迎えますが、今では航空機以外にも人工衛星、車両、ドローン等により得られるセンシングデータから地理空間情報を収集し、
I have a second camera view actually here.
写真を撮っておいてほしい。
So here you can see the vehicle is sitting on the pad. It's currently getting fueled right now. It's quite a long process with hydrogen and oxygen because, of course, both of these are cryogenic, and hydrogen especially cryogenic. So you have to fill it all the way right up to the last second. So yeah, expect it to be filling for the entire duration of the loading period here.
することができます。見てみるでは利用者は関心エリアや観測期間を設定するだけで簡単に衛星データの検索閲覧をすることができ、続いて処理仕様を指定することでオーダーを行うことができます。第3号から得られる高品質で利用用途の広いデータは衛星データ利用の市場をより一層ダイナミックなものへと変動させていくと確信しており、
Go over a bit again the expected launch sequence that we're going to be going through here. So this is a new vehicle, of course, so we should be aware of what we should be expecting as this launch occurs. I'm not totally sure exactly how JAXA's streams work because I've never streamed a JAXA launch before. So I'm hoping they have an onboard camera, but in the event they don't be too disappointed because it's kind of like a SpaceX thing, I would say, to have all of the telemetry. But yeah, at T-0, which is going to be in 18 minutes, we're going to see the launch of the vehicle, which is going to have the boosters and the core stage all igniting at once. And after about 100 seconds, we're going to see that the boosters are going to separate because they'll have finished their job at that point, and they'll basically just fall back to the Earth, not being recovered. And the core stage will continue for another couple of minutes, at which point it's going to run out of fuel. That first stage is going to then separate from the second stage, and that first stage will again also just continue out into the ocean and crash into the ocean, again not being recovered. That second stage is going to ignite, and it's going to take the payload basically all the way into orbit. And then somewhere along the way, those fairings are going to separate and basically reveal the payload underneath. Those fairings are required in order to protect the payload from the aerodynamic forces on the way up. Basically, if you don't have those, the payload can, of course, get dislodged, or it can be damaged by the wind. There's a lot of wind because basically the vehicle is going to be supersonic on the way up, and in the lower parts of the atmosphere, obviously that's not a good thing to just have your payload in the wind like that. But once you get into an altitude above like 80 kilometers or so, there's basically no atmosphere left, so you can basically ditch those fairings and get a little bit extra performance out of your rocket. So you'll see those fairings come off probably somewhere between the before the first stage stops or right after the second stage ignites. I'm not exactly sure where. Again, a new vehicle, we're going to find out. And then if you just want to, I also just want to show you the things that are interesting about this vehicle and why I think it's competitive with the Falcon 9. Because, you know, you might look at me and be like, how can it be competitive with the Falcon 9? They're not even reusing anything. Everything is just expendable, right? How could it compete? Well, if you get into the numbers, it actually is quite competitive. So you'll see here that on the performance level, they're actually quite similar, the H3 and the Falcon 9. They get similar payloads to geostationary transfer orbit. And the H3 gets a little bit less payload into low Earth orbit. But if you look at that realistically, most payloads that Falcon 9 takes to low Earth orbit are less than 10 tons. So all of those could be accommodated on this H3 vehicle. So basically, the H3 can do all the jobs that the Falcon 9 is usually doing, which is interesting because when you look at the price that they're being sold at, you'll notice that the H3 is significantly, well, not significantly, but noticeably cheaper than the Falcon 9 because it's being marketed at 50 to 65 million, whereas the Falcon 9 right now is marketed at 67 million. So for customers who are a little bit more sensitive to cost, I think they might be leaning towards a launch with this H3 vehicle. Of course, if you can save, 10 to 15 million on a launch, why not, right? So it'll be interesting to see if the H3 is able to get a record of reliability where they might actually be able to start stealing customers from the Falcon 9, which would be unprecedented and something that hasn't happened in 5 or 10 years of spaceflight. So looking forward to hopefully creating a bit of a price war between these two companies. And maybe it'll incentivize SpaceX to finally get the Starship moving a bit quicker. Because they'll need to, just to stay competitive. Yeah. Anyways, it goes to show you that just because a rocket is reusable doesn't necessarily mean that it's going to always be cheaper and more effective. Sometimes you can still get away with expendability solutions, at least at this point in the game. Once SpaceX gets full reusability down, I think that'll pretty much be a game changer. But until then, H3 can still be competitive. So here we see, I guess, some of the integration that they do with this vehicle. Of course, Japan is kind of a big place, and they make all of these in different places, so they have to kind of move them all around. But yeah, integrating this type of a structure is always a challenge. Look at the size of these tanks, my god. Yeah, you're right. Japan is not ideal for a lot of orbits. Mostly those orbits that go into kind of circular around the equator. So low inclination orbits. Japan is not ideal because it's way up in the 40 to 50 degrees of latitude. They are launching this one from Japan, but it's fine because they're going into a sun synchronous orbit, which means they're going into a polar orbit. So the orbit is going north to south, not east to west. Basically, in those situations, actually launching higher up is actually better for your delta V. So you actually get a bit of an advantage the further north you are. Today in the commercial economy, going into those polar orbits or highly inclined orbits is actually more than 50% of the business. So it's not really too much of a detriment that they launch from Japan. They can still capture quite a large segment of the market. When they go into the geostationary transfer orbits, though, that's where they pay a bit more of a penalty.
Bring in the units here and doing the assembly. H2A and B, they also went through more or less the same process, but as I said at the outset, this is quite large. H3 is quite large, and so it was quite a significant amount of work.
H3 is large is a bit of an understatement. It's literally bigger in volume than the Falcon 9.
And we were actually there, and we were actually walking right next to it, and I was in tears almost because in anticipation when the H3 was moved. Now, it's actually on top of the launch pad, and beneath the launch pad there is a lorry, a truck that actually will transfer the launch vehicle, and the speed is a little bit slower than people's walking pace, and it's only 400 or 500 meters of travel, so it only takes 30 or 40 minutes for the travel. But when you actually look at it from right next to it, it's quite a grand view. H3 launch vehicle is kind of embedded into the launch section. You may have realized this when you watch the video. And but at the start of the launch, the ignition may not look all that visible, but the launch vehicle is quite large, and the assembly building.
The reason why the launch isn't won't be so visible when they ignite is because the liquid engines actually don't produce. They produce a colorless flame, so you might not even notice when they initially get ignited, but you'll see some smoke and stuff. That'll be your indicator.
Of the H3 launch vehicle flight sequence.
Basically, the sequence that it's going to go through is it's going to ignite those liquid engines first, and then they'll be running, and once they're running and happy, then they ignite the solid rockets, and then they let it go. So it's kind of a lot like an Ariane 5 launch, actually, to be honest with you. And of course, it's kind of like an Ariane 5 configuration, so it kind of makes sense. Yeah. So yeah, if you're used to watching the Ariane 5 launch, you won't be surprised by this one. It's basically kind of a really similar setup as the Ariane 5. It's just, you know, a little bit less powerful. There you're seeing the deorbit burn. So the second stage is actually designed to deorbit itself. So it doesn't just stay up in orbit and become space junk. They leave a little bit left in the tanks so that basically it can flip itself around and then ignite for another a fraction of a second so that it can basically allow itself to come down. This is kind of like a new thing for most launch vehicles that get developed today, is basically they have to have this functionality. Otherwise, you're not being a good steward of space. So we don't want to get ourselves into a situation where space becomes inaccessible because basically, you know, a bunch of junk is floating around and preventing us from being able to launch stuff.
So we have LCC, the Launch Control Center, and the RCC, the Range Control. These two the control centers, they have different roles. In the case of a launch control room, they are responsible for preparation work towards the launch and also countdown. They are also responsible for
just a
RCC,
reminder, we are
the
8
Range
minutes
Control Center.
away from the launch.
They are responsible for tracking the vehicle after launch, and so there is the ground station, but the operating the ground station is also responsibility under Range Control Center. The launch is imminent, and so from here we're going to utilize the live image from the launch pad and live commentary from RCC.
Okay, so we're getting closer to launch now. We can see that the vehicle's coming closer to being fully fueled. You can see like the clouds kind of coming off the vehicle in the different spots where they're fueling. That's basically because they're loading cryogenic propellant. So they're always going to be venting a little bit in order to keep the fluid inside at a pressure that's tolerable. And those like cords you see that are attached to the vehicle, those are basically right now they're fueling the upper stage. So there's a liquid oxygen hose and a liquid hydrogen hose that are basically connecting to the vehicle and doing that functionality. And you can see kind of in the middle of the vehicle, which is the oxygen tank actually for the first stage. You can see that it's kind of some puffs of smoke are coming off. That is just condensation as the liquid oxygen hits the atmosphere when it gets vented.
Range safety system is go. Range system is go.
Good that ranges go. Sometimes boats get in the way. Good to see that's not the case here. Weather is also looking pretty nice, so I hope weather is also a go in the end. It's a good question why they called it H3. I'm not exactly sure why. I have a suspicion. The previous rocket was called the H2B, so after H2 you have H3. It's the third one. I don't know. Engineers are often very creative when we name things. We just number, right?
Celsius. Wind is 0.8 meters per second from the west-southwest. The weather is still a goal, and currently there is no constraint for launch.
本日の打ち上げ予定時刻は日本時間の午前10
This is
時
perfect.
37分55秒です。
I'm getting a little bit creeped out by the altitude numbers that keep going up and down erratically. Well, it's just sitting on the pad. It should just say 70 because the tip of the nose is at 70 meters. But for some reason it's bouncing around. It's probably attached to a
打ち上
barometer
げ
or
5
something.
分前です。
It's 5 minutes to launch.
衛星系準備完了。
Satellite system is go.
Yeah, if it's being controlled by a barometer, basically changes in the atmospheric pressure that are just, happening because of, wind patterns and stuff, obviously can give you some inaccuracies. But it's just funny that it moves around while it's just sitting there on the pad. Hopefully they're not using those values for anything important. Hopefully we don't have any more interruptions.
H3 is now operated under the command of Takesaki Launch Control Center.
18、17、16、15、14。
Alright, 3.5 minutes. We're getting there. I have to say, it is a gorgeous day there at the launch site.
Pressurization process
Just with
of
like the
second
ocean
stage
right behind it and
liquid
stuff.
hydrogen have been initiated.
98、97、96、96、95、94、93、92、91、190、89、
I also find it interesting that they count down all the way from like 5 minutes.
84、83、82、81、180。打ち上げ3分前です。
3 minutes to launch.
76、75、74、73、72、71、170、69、1段液体酸素、液体水素、地上油圧開始。
Pressurization process of first stage liquid oxygen and hydrogen have been initiated.
機体の電源が外部から内部に切り
So
替えられました。
The power have been switched to the internal systems.
they're also going to have to run some fluid across the turbines on the core stage in order to start up the engine itself. And that's going to happen just a couple of seconds before they ignite the engine. I don't know if they'll call that out, but it is an important step. They also need to pressurize those tanks, the liquid oxygen and hydrogen, because the pumps that are pumping those fluids, they need to accept the fluid at a pressure. If they are not pressurized, then they run the risk of cavitation, which is basically a situation where the pump tears itself apart because it's not sucking any fluid. It has to always be having some fluid to take in. If there are any air bubbles or stuff like that, which will happen when the fluid's not pressurized, yeah, you can really damage your pumps.
Pressurization process of second stage liquid oxygen have been initiated.
So that's why you always have this pressurization period. So basically they fill it up just at 1 bar, but then they actually fly at something like usually 4 to 7 bar, and that's just to protect the pumps.
One minute to launch.
So now the vehicle's probably going to be going on internal power, so it now has the control.
Flame deflector cooling is initiated.
I think we're going all the way here, guys.
29、30、31、32、33、34、35、36、27、28、29、28、27、28、29、25、26、27、25、26、27、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29、28、29
All right, here we go. You can see some of the plume that's coming out there. It's because they're starting to run fluid through the actual engine itself. And that's just to get it started.
Hydrogen pros igniter on.
Now the hydrogen is being sent through. They're igniting that engine there.
Main engine start.
Liquid engines are on. Now they're going to ignite the solids. Any second now. Okay, maybe not. Yeah, I think this is a scrub. So something on the vehicle must have said, okay, don't ignite the solids yet. The sound is maybe a little bit weird. Okay. I think the vehicle is safe at least, so this is good. I think basically something was going wrong in that initial startup process, and the vehicle decided, okay, shut down. And thank God it did that before it ignited the solid rockets, because otherwise that would have been bad. And they won't have a chance to recycle this because those liquid engines are already ignited, so they've already drawn fluid out of the tanks. Basically, they would have to refuel at this point. Otherwise, they won't have enough fuel to get to orbit. So I think this will mean that they're probably going to delay until a couple days from now or something. Yeah, this is part of the process.
管理主任より打ち上げ作業関係者に連絡します。ただいまメインエンジンは着火しましたが SRB3 は着火しなかった模様です。現在状況を確認中です。
This is an announcement from the Takesaki Range Control Center to all launch operators and personnel. We have a report that the main engine was ignited, but the SRB3 were not. We are examining the situation.
Yeah.
繰り返します。ただいまメインエンジンは着火しましたが SRB3 は着火しなかった模様です。現在状況を確認中です。
Repeat. This is an announcement from the Takesaki Range Control Center to all launch operators and personnel. We have a report that the main engine was ignited, but the solid boosters were not. We are now confirming the situation.
Yeah, exactly.
打ち上がっているはずの時間になりましたが、まだ
So it should have been launched, but the H3 launch vehicle still remains in the launch pad, and there was a broadcast or announcement. Based on the announcement, the main engine was ignited, but SRB3 did not ignite. But we are still confirming facts, and so in regards to what had happened, we will provide you with an official report. But we are still trying to confirm the details, so please bear with us.
So yeah, you can tell it's quite clear that the SRBs didn't ignite, because if they did, you would know. That thing would have flown away, obviously. But the liquid engines did ignite, and they were ignited for something like 10 seconds. So it seems like they were working correctly, but it could be that basically the computer decided, well, something was not quite right with the liquid engine, and then decided to shut down the liquid engines, and then maybe that also halts the ignition of the solids. So that's one potential cause of all this. The other potential cause is that the SRBs just failed to ignite. So maybe they were supposed to ignite and didn't. And then the computer said, okay, because the solids aren't igniting, I now turn off the liquid as well. So I'm not sure exactly which of those it'll end up being in the end. I suspect that it's probably the first one, because how do you mess up starting a solid rocket? I mean, usually the problem is that they start too easily. But hey, anything's possible. I'm not actually sure what is or how the solids are actually powered. I don't know what fuel they're using, so it could be they're using a more tricky to ignite propellant. Maybe it's something they haven't quite tested as much. I don't know. I think the most likely thing is that there was an issue with the liquid engines. They've been having problems with those engines for like years, so I think it's kind of the most likely culprit in this case. But yeah, new rockets. That's what happens. Sometimes the unexpected occurs, and you know, one thing you can say is that it's always better to scrub than to have an explosion. So yeah, we talked a big game at the start there. This is going to be the rocket that's going to compete with the Falcon 9. Well, I guess they have to work out the kinks first. But again, this is a first launch. Falcon 9, SpaceX didn't have success on their first launches, so you always got to work out the kinks. But yeah, maybe we'll stick around here and see what they tell us about what the failure might have been. But for now, it seems like they're just holding us here. Maybe we can quickly run back and like see what happened just one more time here. Let's see. I'm gonna pull back the stream here to the ignition. So here we go. Let's play from there. So here you see the liquid is going to ignite right there at T-5. It's going full blast at T-2, and then it stops at T plus 3 seconds. So basically it's firing full blast for about 4 or 5 seconds. But I'm seeing lots of sparks at the bottom, so maybe they were actually trying to ignite the solid. Let's try that again. So look to see if you see any sparks for the solid rocket ignition. Like you see it going, it's going, and then they turn it off. Yeah, to me that looks like an intentional shut off. But there's liquid leaking from the engine. It could also be a valve or something. I don't know.
Longer to examine the situation. The status of H3 launch vehicle number 1 will be announced to all launch operators as soon as it will be confirmed. We are ending today's launch status report.
Okay, it looks like that's going to be it. I think this is a bit more of a pernicious issue, so they're going to have some difficulty examining exactly what went wrong. They'll have some difficulty examining exactly what went wrong. Why is it so hard for me to say that?
And as was reported, the main engine did ignite, but SRB3 seemed not to have ignited. But specifically, we don't know the reason as to why this did occur. It may take some time, but as a fact, about 6 seconds before the launch, the main engine ignited and it becomes stable, and count 0 SRB3 was to be ignited, but unfortunately it didn't ignite, and we're trying to investigate the reason for this, and so still trying to confirm the details. And we will continue with this live broadcast for a little more while. And if we identify the reason, we will communicate the cause. But we are still trying to confirm the details. So if you could bear with us a little bit more, and this live stream is continuing for a little while more.
It kind of seems like the solids were attempted to be ignited, because you see that the engine, like typically you would light the solids at T equals 0. That's what I would expect. And you saw the liquid engine was going until T plus 2 seconds. So it seems like they tried to ignite the solid, failed, and therefore shut down the liquid engine. That could be the case. But I've just never seen a rocket fail to ignite a solid rocket before. Like, that seems to be one of the most reliable things throughout commercial aerospace. Like, definitely, Space Shuttle never failed to ignite a solid rocket. I've never seen Ariane fail to ignite their solids. So, yeah, definitely a bit weird if that's the problem. Yeah, the only place where I've seen solids fail to ignite is in the amateur community. Which is, of course, is the community that we're involved in. So, but I expect the professionals to be maybe a bit more capable in these situations. Have their systems a bit more tested. Yeah, to give you some context about who I am, I'm the chief engineer at a rockets group that operates out of Bremen. Basically, we're trying to build a rocket right now, which will go to space. It's a target that a lot of the people in the amateur rocketry community have, because it's, you know, kind of like a difficult milestone to reach. And there's only one student group that's been able to achieve it so far, and we're hoping that we can be the second. And we also want to, of course, you know, break that record. So we're not developing a hybrid we're not developing a solid rocket. We're developing a hybrid rocket, which means that we're using both a solid fuel and a liquid oxidizer. So yeah, in terms of igniting rockets, I would say that's probably one of the harder ones to ignite. So solids kind of seem like they should be easier. You basically just have to make some heat and they should go, you know? But yeah, this is why they do these tests though, right? To make sure that the system is working before you put anything crazy valuable on top of the payload. In this case, there was no loss of mission. There was no loss of vehicle. Everything is still working on the launch pad. Nothing is damaged. The only thing that happened is they basically shut down the engine. And it was clear that the solid rocket boosters did not ignite. Had they ignited and there was something wrong, then there certainly would have been a fireworks show. Because once you light a solid rocket, there's no going back. It's on until there's no fuel left. So if there was something wrong with the liquid engine, then it's definitely a very good thing that those solid rockets didn't ignite, because then this would have ended in a fireball. But yeah, it's quite clear that we're not going to see a launch today, because we're now past the launch window. It was from 10:37 till 10:44 local time for Japan, and we are now at 10:51 local time in Japan. So we're past the launch window. This is definitely going to be scrubbed until a later date. I'm not exactly sure which date that will be yet, but you'll see an announcement from JAXA as to when that will occur. We're just waiting here to see if they make an announcement about what the problem might have been. I highly doubt they're actually going to give us any information at this point, because it seems like a problem that requires a little bit more investigation and digging into what actually happened. As far as what we know right now, we know that the liquid engine ignited. It was started up at T minus 5 seconds. It was at full thrust from T minus around 2 or 3 seconds until T plus 2 seconds. We would normally expect the solid rockets to be ignited at T minus 0, but it was quite clear that those solid rockets did not ignite. And I suspect that is probably what led to the shutdown of the liquid engine, most likely because the solid rockets did not ignite. It could also be that there was something wrong with the liquid engine, and the computer decided, okay, shut everything down, don't ignite the solid rockets yet. But given that the liquid rocket was on past T plus 0, I would say that the solid rocket failure to ignite is probably a more likely option. But yeah, we'll see what they say. Yeah, definitely not quite exciting as a failure, as you might see on some other first launch attempts. But exciting is not good, usually, for the rocket companies.
はい。まだ新しい情報はこちらに。
We have not been able to obtain any new information at this point in time, but I apologize for having everyone wait, but there was a report before in the live broadcast, and they were only talking about what had occurred as a phenomenon. So the main engine did ignite, but SRB3 did not ignite, and this was quite obvious by looking at it as well. What I thought was that normally the main engine, 6 minutes before the launch, would be ignited, and when it becomes stable and when the count is 0, then SRB3 should have been ignited.
Exactly.
But it seems that did not occur, and they're investigating the cause for this. And we were hopeful of being able to communicate the reason, but we are still waiting for updated information. But we are still trying to confirm the situation. And so if you could bear with us, we will still continuing the live stream.
Yeah, so he just confirmed there that the liquid engine performed exactly as it was supposed to. It lit at, again, the T minus 6 seconds. It was going past T minus 0, which indicates that the liquid engine was probably fine. If there was something wrong with the liquid engine, it probably would have shut down earlier. It wouldn't just burn for 6 seconds plus if there was an issue with it. So that seems to indicate that the solid rocket booster, there was an issue with the ignition system on the solid rocket booster, which is certainly a strange failure if that is the case. Also a very dangerous failure because, like, think about it like this. You basically have this giant, like, building-sized volume that's filled with rocket propellant, which is basically a fast-burning substance. And you have some sort of igniter in there that is supposed to trigger the reaction that turns this whole thing on, right? And if that fails to ignite, at that point you basically have very little information. You don't really know, like, okay, is it armed? Is it not armed? So how do you go and investigate that? Because, like, basically if you send somebody over there to do something, but, like, the igniter is still armed or is still able to trigger a reaction, obviously very, very dangerous. So usually you have to build in mechanisms so that you can disarm an igniter even if you have a failure to ignite scenario, which is difficult to think about usually because you have to basically think about all the ways it can fail. Another reason why I doubt they're actually going to come back with information immediately like this, because basically, well, there's probably a whole procedure they have to go through in this situation. I'm just thinking from my perspective, because in amateur rocketry you have the same problem, which is that if you have a rocket that's sitting there on the launch rail and you push the button and nothing happens, again, you're in that same position of, like, well, okay, is my igniter, like, still armed and working? So if I go over there and try to play around with it, am I going to have it blow up in my face? Yeah, so obviously you have to disconnect everything, and there's a whole procedure you should go through in order to make sure everything's not connected, and there's no way that you can accidentally trigger the ignition of the rocket. Yeah. Not an easy failure to recover from. They probably have to go in and, like, they'll have to, like, reconfigure the solid booster altogether, because the igniters are usually, like, way up the butt of the rocket, and they'll be, like, connected to the top. And if you want to take out that igniter and put a new one in or something like that, you basically are doing some pretty serious reconfiguration of the actual booster itself. So it could take like days, you know. So I suspect they're not going to have too quick of a turnaround if this is actually the issue. It's the igniter, you know. Unless their failure is just like a communication failure. Like maybe it's just that, a signal didn't quite get received somewhere and, the thing just didn't do anything. If that's the case, then it's probably just a quick fix. But yeah, if you guys have any questions about the H3 launch vehicle, or maybe you have some theories about what happened here, please feel free to share in the comments. We can kind of be detectives a little bit and try to figure out what went wrong. I would recommend that you follow JAXA on Twitter or something, because usually that's where they would release information of this type. They're typically reasonably good at communicating with the public as to what's going on within the agency and, little problems that come up and stuff. So it's really too bad we didn't get to see it launch, because it's such a gorgeous day. Like, look at that. The way it's just situated right there on the peninsula with the whole, tropical vibe. Like, beautiful blue ocean. You got a nice beach there. Open sky. We would have had great video of this thing going up. And the visibility is fantastic. I'm sure you would have seen that rocket nearly all the way to orbit with just the tracking camera. Oh well, I guess it's not to be. Doesn't look like we're getting much of an update here. Yeah, I don't know. Maybe we take a little bit of a break, and if they come back, then we'll pop back on. So yeah, don't go away for too long. All right, so I think it's quite clear at this point that we're not going to get an update in a timely fashion. So I think we'll just end the stream there. We should be not too worried, though, I would say, about the H3 rocket. I think this failure is just something they had to work out in terms of the kinks, in terms of launch operations. It can be quite a complicated process, and lots of things can come up that you don't expect. And you kind of have to work through those when you're starting to go through launching a new rocket. So I expect these things to be worked out over the next couple of weeks as they try to figure out what exactly went wrong here. And I would expect the H3 rocket to be back relatively soon. And we should be very thankful that the computer was smart enough not to light the SRB, or lucky enough that it didn't ignite, because they could have created a much bigger problem. Scrubs are always better than RUDs. Remember that. All right, I hope you learned a little bit along the way here, and remember to keep expanding your horizons.